Hi, my name's Jordan Marshall and I'm Chief Reporter at Building Magazine, and I'm chairing today's session this afternoon, which is our second one in our Education Estates event day. Really excited about this one, lots to learn. So it's all about acoustic standards in schools. I'm joined by Justin Lewis and Will Wigfield. And so the way today's session is going to work is Justin and Will going to run us through a presentation on the CPD module, and then any questions, please have them coming through and I will be going through those and then facilitating a Q&A session at the end. There is also a video included within this presentation. When that plays, for some people, you just need to flick your audio channel, which will pop up if you need to do that. But if there's any issues with the audio on that video, please just let us know, and we'll make sure you get a copy of it at the conclusion of today's session, which will also be available on demand. So if you enjoy the session so much you want to watch it again, or you think someone else in your team has a lot to learn by watching it, please just share the link. It's the same one that you've used to join just now, usually available within about 30 minutes of the session wrapping up. So yeah, we'll be available on demand, still for free, via the same link you joined today. That's probably enough for me. So I'll hand over to the guys and let things get underway.
Brilliant. Thank you, Jordan. Good afternoon all, and thank you for joining the CPD today. So today we're going to talk about acoustic standards in schools, something that we've been very involved with over a number of years here at ROCKWOOL. Obviously, there's many attributes to our products, including thermal, fire, and obviously not to forget acoustics, the acoustic properties of our product. So just a little bit of history on the journey to now, and obviously acoustics within schools is important. We often find that it can be the fact that's missed when designing an education facility. So back in 2003, BB93 was introduced as a guidance document. It was non-legislative, but it was produced by the Department for Education to look to set a minimum criteria performance standard for new build educational facilities. In 2008, that was enforced as a legislative document, still only with new build, but it was enforced by the government that when building an education facility, you needed to comply with the regulation of BB93. We jump up to 2013, which was the first and major improvement really to BB93 when the document was overhauled, went through a number of different consultations, and it actually then brought in refurbishment projects. So we can't forget about buildings that were built many, many years ago, needing the same acoustic standards that we would like our children to learn in today. We then come up to 2015 when the document was actually launched to the market, which was February. It was some great Christmas time reading just before for some of us who were involved in the consultation, but we just wanted to make sure that everything was correct before it went live and into the market. In 2015 then, in November, it had a design guide about how you could comply with some simple design guidance of products to include. And one of the items that's mentioned in there is high density stone wool. That will come on to a little bit later in the presentation with regards to our roof system offerings. So the learning objectives for today, and hopefully you'll take some of these away with you at the end of the presentation. So we're looking to educate on the importance of acoustics in schools, demonstrate the different types of sound disruptions, identify regulation and standards, and they're the relevant ones that we want to highlight, and as I already touched on with BB93 in particular, and show different available solutions to help those results get achieved. And obviously we're always here to help as a business if guidance is needed after that. So, importance of acoustics in schools. I know a lot of people say that it's only acoustics. You can leave that to the back burner. You know, we've got the thermal requirements to achieve. We've got fire requirements, obviously both very important, but on that same level, acoustics are just as important. So it impacts over 4 million pupils and staff. Acoustics account for key priority within a school design, and we've always found that if it's taken into the design account early enough, it can be built in. You haven't got to look for ways to get around things at a later date, add additional mass layers in, or maybe put an additional layer of plasterboard in here and there. You can do it from the outset with the design taking into account the products that can be used to achieve these criteria. 40 years of research shows noise and poor acoustics can lower pupils' academic performance. compromised classroom control, so that's where a teacher's trying to take control of the pupils in a classroom, and I'm sure we've all been there at some point. Damaged teachers' health. We've seen certain claims made against the Education Funding Authority, where teachers have had voice strain from having to raise their voice consistently during classroom time. So all of those things need to be taken into account. And again, last but certainly not least, disadvantages for children or even young adults with special educational needs, such as autism. Acoustics plays a vital part in that as well. So some of the items that we have seen. Oops, sorry, one too far. Okay, so partially deaf children overlooked at school was a report back on the 5th of May in 2015 by the BBC, where it went in to say that there was different standards being achieved in specific schools because children with difficulties weren't getting the same attention and they were being overlooked. So that was needed to be addressed by the EFA, Education Funding Authority. And then we see the lower one, where quiet is at the back. Why classroom noise is the enemy of learning. Obviously, when you're at the back of a school classroom, by the time the teacher's voice gets to you, if the correct measures aren't in place, it could be echoey. You may not be paying full attention. And obviously, acoustics can help to control that environment to ensure that everybody learns adequately and correctly, and obviously gets the most out of what they're there to learn. So then we look at some of the impacts and the effects around us that have an effect on a school building. So weather and noise, aircraft noise, duct-borne noise from ventilation or air handling equipment that is on or around the school, noisy corridors, obviously sound transferring between floors, again between corridors, between walls, air conditioning ducts and so on that may be in place around any given school. You've then got traffic noise and vibration from outside. And I know from being involved with a number of schools over the years, but also we previously had an office in London which wasn't the best insulated. We've since moved, by the way, I'll hasten to add. But we were in the flight path to Heathrow Airport, and the aircraft noise coming from that certainly had an impact on us within that building. You could hear you could feel the vibration, you could hear it. So the correct acoustic treatment can certainly help and make sure that people can learn and work correctly. So as I've just touched on, obviously noisy ventilation can create a problem. External noise, aircraft noise, traffic noise, even playground noise. So if you've got children who could be on a break time and you've got other children trying to learn in class, the noise from outside coming through a facade of a building, that can have an impact and a negative impact at that. Noise from adjacent rooms and obviously the equipment. Certain things that always spring to mind with me when I was in school many years ago. We had a server room, and that server room obviously was holding, PCs aren't what they are today and servers aren't what they are today, but it was holding a server facility, and that was really noisy, pumping out hot air amongst a really noisy fan, keeping it cool, trying to keep it cool. And unfortunately, that disrupted the classrooms either side of it. So again, acoustics can help, and the right products used to deal with the acoustic control can assist with that.
Yeah, just on the internal ambient noise levels as well. We often get asked, what build up or how much ROCKWOOL do we need to meet a certain internal ambient noise level, because that's how the regulations dictate performance. But you have to take into account the existing acoustic environment. So without that acoustic survey, then we're not able to help. But it's just important to kind of bear that in mind, what's actually required.
Thanks, Will. So regulation and standards. Obviously, there's a number of these within the industry for different sectors. Obviously, as we're talking about schools today, the one that certainly comes to the forefront and is the most important, as we've already covered, is legislation, and it is Building Bulletin 93. Obviously, many people we hear, and if I look at specifically a roof aspect, if they say that they've used a ROCKWOOL acoustic infill, which is typically there for absorption, they believe that the full acoustic requirement is satisfied under the requirements of BB 93. What that doesn't take into account is, as Will has just touched on, the internal ambient noise level, so the maximum level that can be and how that's controlled. You've then got rain noise or impact, so noise from above. And again, if we're looking at a roof system, that plays a vital part. We don't have the warmest climate in the UK. We are susceptible to a lot of rainfall, and it certainly does have an impact on these buildings. sound insulation, so you're looking between spaces. And as I've mentioned, the acoustic infill, the one bit that would help with satisfying of BB93 is reverberation. I'll come on to a little bit more of an example with the reverberation a little bit later. So then when you actually look into the document within BB93, sorry, go back when it's jumped again, I believe. Oh, sorry, this is the reverberation slide first. I'm getting ahead of myself. So with reverb within the BB93 document, we look at reverb, and I do apologize. So we're looking at reverb within BB93, so one element of, and obviously each room criteria can be different. This is just a snapshot of an element taken from BB93, so we can see where we have an indoor sports hall or swimming pool, we have a reverberation time allowance of less than 1.5 to 2 seconds. So that's measured obviously with how much the sound is being absorbed within that space. You've then got a resource stroke breakout area or dance studio, less than 1.2. And you come all the way down to a teaching space for students with special hearing or communication needs, where you're at less than 0.4. So where you're at the top end, you would look to use something like a ROCKWOOL acoustic infill within a perforated deck. That would satisfy the requirement. Where you come down to the teaching space where they're looking for a 0.4, you would have a very onerous ceiling tile in place to make sure that is controlled. So then when we look at the key considerations, we've got to look at the size and geometry of the room. So the image you see here is a sports hall. And this certainly takes me back to when I was in school. And if we had a leak in a classroom, or a classroom was out of action for whatever reason, then ultimately we would be moved to the sports hall to have a lesson in whatever it may be. Unfortunately, the sports hall that was at the school I was at had very little, if any, acoustic treatment. So if I was sat from the middle towards the back of what was set out as that classroom, unfortunately, it'd be very unlikely that I would hear what the teacher was saying correctly. There would be an echo, there would be delay. And obviously with those two mixing together, you're never going to learn, never going to understand what is actually being said. So we always guide that, where a sports hall is being used, possibly for doubling up as a classroom, but also will be used during examination time. Obviously, two key points that need to be raised with regards to consideration for designing a sports hall. Acoustic infills in a perforated metal deck is the way to go to look after satisfying the reverberation control. Where you then come to maybe a main hall, or if you've got an assembly hall or typical classrooms, you kids could still look to use the perforated metal deck with acoustic infills. You'd probably need an element of wall absorption as well to ensure the criteria is achieved. But failing that, you would go to a suspended ceiling. And part of our business is ROCKWOOL ceiling tiles. They have solutions combined with our roof solutions to give a BB93 compliant scheme. Obviously, when we say BB93 compliant, obviously the criteria is set out, but as Will has already referred to, there needs to be an acoustic document produced for where that site is, where that school is being built, because that's the actual data. You need to know how the surrounding areas work, what's planned for the future for that surrounding area, and then look to ensure that the requirements are still being achieved even when that area is fully developed. So then we come on to the internal ambient noise level, and as it's referred to in BB93, the IANL. Obviously, this affects teachers' abilities to be heard and understood, and students' ability to be able to concentrate. So again, it's about having the right controls in place. The right measures have to be put in place to ensure that room performs acoustically correctly within that building. Obviously, sources, as we've touched on here, HVAC installations when you've got ductwork and so on running above and through possibly areas of classrooms. Classroom equipment itself, so as I touched on with like PCs and so on, some can be noisy. Other equipment that may be in that room could be giving off a hum, which can take people's attention away from what they're actually doing. You've then got traffic and aircraft noise, adjacent rooms and corridors. Obviously, as pupils are leaving, trying to get out of school early, if they finished a little bit earlier than the class next door to them, you're going to have that impact of that sound transferring through into the room that's still trying to be taught in. And then the increased by high RT, the Lombard effect, which is the delay in sound and the decay of sound getting to the people at the back of the classroom, etc. So we take another snippet out of BB93, and this is where we're looking at rain noise, so impact noise. And again, predominantly this element is looking at a roof function, albeit it can be taken into judgment for flooring as well. We'll come on to that in a little bit. So there is a set internal ambient noise level that needs to be achieved, and as we say, when this was updated in 2015, it introduced refurbishment. So the new build was in place. So typically the internal ambient noise level for an indoor sports hall is 40 decibels. With a refurbishment, you're allowed to go 45. So in speaking with Will, and Will's the expert on this, this is where you've got to take into consideration that there'll be something in that construction, and there's allowances made when you look at the refurb element. I'm correct in saying that, Will?
Yeah, that's correct. I mean, when it comes, I mean, with all things to do with acoustics, if you get the specification right from the get-go, it's much more effective, much cheaper ultimately to get, really good results. With refurbishment, though, there's a limit to how much you can do and how effective some of the measures can be, and also the cost tends to be a lot higher. So I think there's a recognition of that in the standard, which is why the targets there are slightly relaxed for refurbishment.
Thank you. And also you can see here there's a number of classrooms laid out, different types that have different requirements. And obviously you can look to mix and match under one roof, shall we say, but you'll often find that you'll work to the worst performing space to ensure that everything is achieved. And so that's what we've experienced over a number of years. So obviously rain noise can significantly increase indoor noise levels. And I certainly know when I've been in different shopping centres that may have a panel roof system, a metal panel roof system containing a rigid insulate, obviously perform thermally very, very well. But however, when you're under a rainfall, you certainly feel it and hear it within the store. And in some regard, it's been so noisy where I actually struggle to hear what somebody else is saying. And they'll often say, oh yeah, we experienced this problem considerably a number of times throughout the year. Just bear with us a second, the rain will pass and we'll be able to continue the conversation. We've also seen it within certain like car showrooms, and of late we have seen some schools come back to us and ask for updates where they have used panel constructions on their roofs because they've been given some acoustic data which they understood was satisfactory, but they've had feedback from pupils, etc., complaining that when it rains it's very, very noisy. So again, we're involved in those type of projects to ensure that we combat rain noise, because it is one of the biggest frustrations we feel we hear as feedback. So in some cases, that pressure internally is achieved 70 dBA, which is very high indeed. I know we used to have a small demonstration sound here, but we haven't included it in this presentation. But just to give some kind of feeling of the impact, obviously when you hear a recording, it's not quite the same as actually hearing it in person. But yeah, there is quite a difference when you just put a layer of one of our products within there, depending on what the construction is. Building regulation submissions should demonstrate that lightweight roofs and roof glazing have been designed to prove suitable control of reverberant noise. And again, this is something we've seen more of recently, where we're getting asked for the data beforehand. That in addition can come on to the next point, where you can gain BREEAM credits for proving the acoustics work before it's actually installed. And any BREEAM assessor who's involved with the project should be able to assist with that, and we can provide that data. And as it says there on the slide, obviously with regards to rain noise, that sits above the internal ambient noise level by a 25 decibel rating. So managing rain noise, obviously the bigger the surface area, the bigger the potential problem. So sports halls, assembly halls, they've got large surface areas, and it's about controlling that impact, the impact hitting that roof and obviously transferring through that roof system. We've done many tests, and Will and I have spent a long time over the last 6, 7, 8 years in different acoustic laboratories, trying out different methods, trying to make different things work. And again, some of them, even Will being an acoustician, I think some of them have shocked him how the performances have come out. And it's all about making sure that you've got the right products in there from the outset, from the design outset, to ensure that the performance is maintained throughout the build process, and obviously it will work once in situ. That then takes into account obviously the metal cladding, lightweight roof systems that don't have a void, because obviously if you've got a void, you could pack it with something which will assist. If there's no void there and it's just the underside of the metal deck being the soffit, then obviously the system above it needs to be doing all the work. Separately to that, obviously the performance of roof lights. We've been asked many a time, we've got your data, this performs, this is exactly what we need. However, we're going to drop 6 or 8 roof lights in it. That question then comes back to, okay, so where's the test data on the roof lights? So some roof light manufacturers now have data. Obviously, they've caught up with the trend in the requests coming through. We've also got some data where we've got 1 or 2 specific tests that we ran for particular clients where they wanted to use a certain roof light or sun tube, and we had to make sure that the data worked when it was used in comparison with our system. And obviously, manufacturer test data is measured in accordance with BSEN ISO 140-18 for a proposed system. And that's a question we see quite regular. People want that data for rain noise for our solution. Obviously, the quote from the design guide on the right-hand side, I won't read through it. Obviously, there's a number of them, but just gives you an idea of how they, the EFA, put the design guide together with some of the little snippets of information that they would highlight throughout. So when we look at performance standards for rain noise, so as we said, if you've got the IANL level, you'd go 25 dB above that to calculate the rain noise. Will, do you want to give a little overview of the correlation between the two?
Yes. So, but basically, to use the data, so you'll have the actual rain noise test, which is done under standardized conditions in a laboratory, and then there's a calculation process you have to go through to adjust it to take into account the size of the roof, the height of the room, the amount of absorption within the room that you're putting the roof over, to come up with what the sort of predicted level or predicted sound level within that space will be, based on that tested roof system. So it'll be a kind of a more bespoke calculation. So you can't just take the test data and say it got a value, therefore I can use this roof. You need to actually carry out a calculation to see if you actually comply with these limits set by BB93.
Super, thanks. Well, again, as you can see here, different classroom types, different room types have different requirements. So this extract here is based on new builds. Obviously, the same applies within refurb, although the numbers are slightly different, slightly varied. So then if we look at sound insulation and some key considerations, and I know we've covered some of these, but obviously we've got the airborne, which is noise is sound transmitted by air, like music or speech. And I know some people say that that's noise, and to some people it's not noise. They actually like that sound, but obviously you've got to try and make it uniform when you're designing and building a school. Impact noise, sound transfer vibration when an object comes into contact with a separating element. So e.g. when you drop something on the floor, you drag chairs across the floor. And I know one of the examples that we've had thrown back at us in a previous CPD was somebody remembers when they were in school and they may be on the ground floor and the class above had finished, they were leaving early, and you had 30 or 40 chairs being dragged along the floor, that sound just transferring through. So again, that wasn't exactly what they wanted in the room below. Pupils couldn't concentrate, teachers couldn't teach correctly because the noise was intruding into that space below. Direct transmission is noise transfer from one room to another via a shared wall. So again, we often see that where you may have a movable partition. You need to ensure that that's acoustically treated as well to ensure that sound doesn't transfer through. You've also got a standard wall system where if the incorrect products are used in between, or there's a link connecting the two from either side, that could allow that transfer also. Flanking transmission is indirect noise transfer from one room to another. So this may hop over the top of a party wall detail or compartment wall, e.g., as we say here, via a suspended ceiling. Obviously, there's ways to prevent that. Where you've got the header wall, you'd have a specific detail to block the acoustic. You may also have it there for fire to stop the fire transfer. But yeah, it can work for acoustic as well. So performance standards, for airborne sound insulation between spaces. So on the left is the new build table, on the right is the refurb, just to show the difference between the two. But obviously these have to be taken into account with regards to the elements being constructed and whether they're new build or refurb. And obviously use it again, back to if you're using the right products, these can be satisfied relatively easily and cost effectively, as Will has said, as long as they're designed in from the outset.
Yeah, I mean, the idea here is to, as much as it sets, well, it assigns different room types, different noise sensitivity or tolerance levels rather. So the idea is less about having to achieve these very high dB reduction figures and more about encouraging people to design scores so that, you know, noise sensitive areas aren't next to, you know, noisy spaces. So, you know, you wouldn't put a music room next to a reading room. It's, you know, kind of common sense things like that. But that's what they're trying to drive at here with these figures, I think.
Okay, so if we then look at performance standards, hopefully that has it gone on too far again. Okay, so performance standards for impact sound. So again, I always link this back to relating it to roof. Obviously, it does cater with flooring as well, but it's about that noise on that roof. Where's the maximum level? What can it go to? And again, different rooms can have different criteria because it'll be taken back to the internal ambient noise level within that space, and then how that roof on that room has to perform. So it could be a floor, could be a roof. And again, it's quite critical that people, we try to educate people within the market to say that, you know, if you're looking for a 55 dB here, for example, that's quite onerous. Whereas when you're looking at something like a 65 or a 70, it's not as onerous. That often gets confused with trying to understand an RW or an airborne rating. We've kind of tried to make it a bit of a layman's term, whereas when you're looking at an RW rating, the higher the number, the better. And when you look at an LIA or this rating here, you're actually saying the lower the number, the better with the way the performance works. Don't know if you want to expand on that a little bit, Will?
Yeah. So here with impact sound, it's to do with the sound level in the receiving room. So, you know, you'll have a noise source on top knocking on the floor, and then you'll measure how loud it gets within the room below. That's why the lower it is, the better. Whereas with RW, that's the sound difference, the dB difference level, sorry, between the two spaces. So in that case, the higher the number, the better, because it's how much sound that wall's resisting.
Thank you, Will. So if we move on to sound insulation. So overview. So we're taking a typical wall construction here, and obviously the rating is expressed through a weighted sound reduction, so an RW. Airborne sound insulation principally controlled by the mass law, albeit that's where it's thrown up a few anomalies for Will and I in the past, certainly when we've been in the test house running different things. It's majority of the time it would go by the mass law, but not always, and it certainly caught us out a couple of times. Typically doubling the mass of an element will increase RW by 6 dB. There's lots of myths in the market that we certainly hear, but promptly it increased the RW figure by 6 would be about correct. Separating two leaves of a double leafed system improves the sound insulation. It's just basically because you're taking, if you like, two rigid elements apart and you're putting something between them that performs acoustically. And then, as it says there, avoid a rigid connection between two leaves will further improve performance. So we've seen that when we take that back to a roof construction. We've seen that where we've used a specific type of fixing that is connecting the metal deck and the outer covering, and whether it's a metal covering or a polymeric covering, for example. If we put a firmly broken fastener in there where the in and out are not totally connected, that can prove a difference in the construction. So hopefully that's just an example to show how when you separate that, it does perform differently. Okay, so now we'll come on to some solutions from us. Okay, so if we click in to our roof offering and the ROCKWOOL Hard Rock DD Multifix product, on the left-hand side here, you have a suite of data, and it is a small suite. It's a snapshot of what we have as a business. We're always looking to expand on this, and we will get asked, no doubt, over the next however many years to run specific tests for certain clients where they need a specific criteria. And Will and I, many times in the past, have picked up on that. And as we touched on just now, we've spent time in the lab making sure that things work correctly. So this is just a snapshot where we have single ply and bitumen data, airborne and rain noise figures, just to show you what is capable. And the figures that you see in the table there in front of you are using our roof board only. They don't have any mass layers. There is no ceiling included. and they're based on solid metal deck constructions. As you see in the image on the right, we can enhance these figures by adding our ROCKWOOL acoustic membrane to the system. There's no set differing whether that adds 1 decibel or 5 decibels. It depends on the whole system build-up, how that system's constructed. There it can have a varying performance because it depends what level you're at already within the hard rock itself. If we then look at the acoustic infill, which sits into the trough of a perforated metal deck, that can actually reduce and will actually reduce the performances you see in front of you because you're taking the mass out of the deck. So that has to go back in some way. If we have the opportunity to look at specifying a system that can increase the hard rock and possibly in conjunction then with an acoustic membrane, that is where we can put that mass back into the system, ensuring the criteria is achieved. We then look at internal partitions. So within our range, steel frame slab and timber frame slab kind of does what it says on the tin. One is used within a steel frame, one is used within a timber frame. And again, Will's picked up on these previously with regards to all of the testing that's taken place, looking at different systems to see how it performs. And we've got options here tested up to 46 dB as an RW, and then metal stud up to 63 RW. Obviously, if any details are needed on these, please don't hesitate to ask us. Internal floors. So this is where we look at, excuse me a second, this is where we look at built-up construction of intermediate floors, where we're using ROCKWOOL products in between joists, and then obviously the flooring system over the top. Here we've got airborne figures of up to 66 and impact down as low as 54. Again, obviously all data is available if needed. So flanking transmission solutions, as we've touched, or as I touched on earlier, where we look at head of wall detail. We've also got products to go around ductwork, rainwater pipes, soil pipe, service and process pipes. We've then got our fire barrier product, which is tested for up to RW50, and our ablative coated back tested up to RW52 dB. And as you can see from a lot of the data that we have, Will has certainly spent a lot of time in the acoustic labs testing all of these products to ensure that they give us what we need for the market. The support from us. We have trained acoustic consultants within the business. And I say consultants, they're people who have been trained to look at different applications. They have acoustic software, they have our acoustic data. We then go a step further and we have qualified acousticians within our business as a group. Will is one of those qualified acousticians, which is why he's so busy all the time doing different acoustic tests, ensuring that our data is up to scratch, is correct. And when we get asked for something further, obviously Will is the one that takes that on and makes sure that we get the results we need, or how we get the results we need. Our library of tested acoustic systems, they cover impact, airborne, sound, reverb, and bespoke rain noise and acoustic calculations we can carry out for you. Obviously, we're more than happy to become involved in a project to look at the best way to make that project perform. So what this means to all of us as individuals, and I'm going to take a pause for a second, and the video hopefully will start playing for everybody when I click play. So bear with me.
It just takes a minute to load up. It will be on in 30 seconds.
I'm really sorry. I don't think it seems to be coming through, Justin. I'm so sorry about that. Sorry, unfortunately, I'm afraid that's not working. What we'll do, that will be attached to the on-demand file. So anybody that's watching this, if you use the same link that you logged in with, then the video will be attached to that and we'll send it all out to you afterwards. Apologies, Justin.
No problem. Thank you for letting us know. Yeah, sorry, guys. I thought I was going to get a 3-minute break there. But obviously it will be attached for you guys to pick up on later. It's an overview of a school that we were involved with from very early days, and it's an autistic school. sorry, just click that one. So yeah, it's an autistic school that we're involved with from very early design stages. ROCKWOOL is used throughout the build in floors, walls and roof, and it just takes you through the feedback from the client, the architect and the actual end user, seeing how well it performs. But obviously you can view that later at your leisure, hopefully. So to summarise and to look forward, it's something that we always say within any sort of assistance that we're giving, any specification support, correct product input into any build, and whether it's thermal, fire or acoustic, we always try to demonstrate and always want to demonstrate our role within that support. And obviously we have a responsibility as a key specifier or key advisor that we guide people correctly. And we simply ask that the people we work with, hopefully they do the same. And it's just to make sure that when we look at acoustics and we look at schools in particular, it's to deliver an excellent acoustic environment so education can prosper. Consider everything that goes into that build, consider everything around that build, all the elements that can impact on it when selecting products. And again, I keep coming back to, for us, it is about those three that I keep mentioning, thermal, acoustic and fire. All three of them have a vital part within any school building. It's absolutely critical that we are trying to educate the market, and we see the pull from the market with regards to the Education Funding Authority. It's just trying to make sure that we're lined up at both ends to ensure the correct products are specified and used. Recognise best solutions to achieving excellent acoustic environments. And we say that we know when there's limitations, for example, on refurb projects, we know that there are going to be limitations and restrictions on height, for example, when we look at replacing a roof system. So again, for us, it's about becoming involved in that project. And is there something we can do above and below the roof? Again, ensuring it works in the event of a fire, it works acoustically, it works thermally. And when you're looking at insulating in that way, ensuring that there is no risk of condensation, because that's the last thing we want is that little one sneaking up on us as well. That just applies to the roof. We look to do the same with every other part of the build as well, where we can, to ensure that the acoustic standards in particular here are achieved. We also look to maintain standards and advice as listed in BB93 now and into the future. So we're always trying to think that if something's going to be built in a busier room, in a busier area, we want that room within that school to perform correctly. So is there a developing area? Is there going to be another runway added at Heathrow? Is there going to be more traffic, more air traffic in that area? We'll try to future protect and see what we will need. Hopefully that moves. So future challenges. Obviously, environmental impacts are changing around schools all the time. Obviously, again, we play our key part with environmental. Our product is manufactured from stone. It's basically rocks melted at high temperature, then produced into an insulation product. So when you look at like BREEAM points and so on, obviously we benefit in that area where the product comes from, and the products are recyclable. They can come off site in 30, 40, 50 years time. They can come back into the mix. The next challenge, as I just touched on, what's happening to certain areas, new airports, expanding airports. You've also got things like HS2 taking place. All of those will have an impact on how one of these buildings can perform, especially when it comes to acoustic and that sound transfer across into the building. And we got here 2022 estimated nearly 400,000 extra pupils to be catered for nationally. So we have redesign challenges. And I know I went to one of the Education Funding Authority conferences a couple of years back now, and they said within the next 10 years that they will be revisiting a lot of the schools that they built in the last 10 to 15 years, because they are going to need to be expanded due to the growth of pupils that will be coming through and will need to be taught in those areas. So obviously we continue to see that growth. So from us, obviously to try and keep up to date with trends, regulatory changes, and basically product updates from us, you can register yourself at rockwool.co.uk/CPD. And obviously we have a whole suite of CPDs that are available. Some of them are now available online on demand. But obviously if anybody wanted a CPD in person or over Teams, we're more than happy to deliver that when it's needed. And then from us, obviously we always look to provide technical expertise, and we're more than happy to. obviously guiding on our products. We have a dedicated sales support team as well as a dedicated technical team. Learning and training, we've got many areas on our website which can assist with different areas, different applications, looking at different product types. And as was shown earlier, we have an online acoustic calculator. So if anybody wanted to run a quick acoustic calc, obviously there's set parameters online. There's a snapshot of some of the information that we've got, but you can create your own acoustic calculator. If you then needed something a bit more in depth, a bit more bespoke, then please feel free to contact us. And again, that ties in with the innovative online tools that we have. And then on that, thank you very much for taking the time out today to listen. I think I was asked at the start of the presentation how long it would be, and I believe I said about 45 minutes, so I think I'm on cue. Had the video run, we'd have been there.
Bang on. That was a really great presentation. Thank you so much. I have quite a few questions already coming in, but I think we should be able to get through them. So if you do have any, please feel free to send them through and we'll try and cover off all the ones that we can. Might as well just jump in with a listener one to start off with. One of the questions I've had come through is in regards to, given that how much you were talking about rain noise and that sort of impact, what sort of effect does it have if you have like a skylight or glass aspect to your roofs, and how does that get built into making sure you meet standards?
You want to take that one?
Yeah, well, there's I mean, there's test data out there for skylights like that, airborne and rain noise. You would have to factor that in as part of the weighted calculation, the overall performance of the roof. So yes, it's a very valid thing, because as we know, rain noise is a much bigger problem with lightweight roofing systems in general. Especially with perhaps rigid insulation types. If you've got something that's just effectively a transparent skylight, yeah, that's going to have its own problems as well. So it definitely needs to be tested and factored in.
And I'm just going to answer a question quickly because we have this one about 6 times. There was a lot of information there. Yes. Will you be able to watch it again? Yes. Via the same link. All the slides and the attached video will be available via the same link, probably within about 30 minutes of us signing off here. So watch it again yourself, share it with your team. It's available free. So that's the one question that I can answer before I turn back to the experts. So here we have another question around, which you guys did touch on, but particularly the acoustic needs in special needs schools and how to cater for that more specifically. And if you had any guidance there or thoughts to share, I think people would like some more insight.
So I think with special education needs, obviously there is a set standard within BB93 itself, where they go above and beyond the standard criteria. The one example that we used was obviously where you have a classroom, they have a lower reverberation time that has to be achieved. Where we then in the past have got involved with like what the case study is on, they actually had their acoustic report. Their acoustician then said to us that we actually want to exceed by X, Y, and Z in different areas. We could then look at what was required in each of those areas to ensure that they were achieved to get the levels they needed. We also know that in speaking with some acousticians, they are involved with more special educational needs projects, and they're saying that they actually, as one example, lower the rain noise criteria from circa 55 to 47. So it just gives you, hopefully that gives you a little bit of an idea of where it would sit, but obviously if you've got something specific, we'd be more than happy to work through it with you.
Brilliant. So we've also had a question come in about sort of like, there's obviously the products that you're talking about, but then there's other sorts of products like acoustic pipe systems and that sort of thing. Is it if you're investing to have the right acoustic wall systems and everything, should you also be looking at like the M&E and other aspects of the building and how that all works together? And is that something that you guys can provide guidance with?
Yeah, absolutely. I mean, it's one of the things that'll affect the internal ambient noise level. M&E, HVAC equipment, all that kind of things, all those kind of things. We have a range of acoustic products for those kind of applications as well. So, if you talk to our technical team, we'd be more than happy to help you address any specific concerns.
Brilliant. So We've had a question come in asking if each of you could sort of highlight what you believe is like the biggest challenge to achieving like the acoustic levels in schools that are appropriate for like the learning environment, and then also, you know, the opportunities for firms to get it right. Like, where does that sit?
I think, sorry, Jordan, just go back, Jordan. Did you say our biggest challenge?
I mean, they have said what is the biggest challenge. So I don't think it's for you specifically, but I suppose for companies working in this space to deliver it, what is the biggest challenge?
I'd say historically, I don't know if you agree, just that the biggest challenge I think we've found is just getting people to recognise and know that these regulation standards exist, because they're not, as much as it's now become it's legislative. It's not particularly well policed. So you know, it's about making people aware of these standards, and then not just aware of the standards, but also how they can then actually meet these levels. That's where some of the knowledge I think has been lacking before. So I'd say that was probably the biggest challenge.
I would certainly agree, Will. Yeah, it's definitely it's the limited knowledge that's in the marketplace. It's trying to get the industry to recognise that it is required, and it's like, for many years I've presented about acoustics to a whole array of people, and you know, a lot of the time you do see their eyes light up as if to say, oh, kind of didn't know about this. Obviously it is interesting. I know a lot of people say it is a dark art, but it also seems to be slightly forgotten. So it is about recognizing that it is there. It does have an impact on everybody's life. And you know, we are here to support, we're here to educate, and we're here to help.
Brilliant. This one's just from me, but something that you touched on there is, you know, looking forward, you know, there might be another runway at Heathrow with more overhead noise. There could be HS2 belt, and it's already well established that there's quite an extensive estates backlog of maintenance that's required on the school estate across the country, with which obviously acoustic work is only one part. But how can people help future-proof in their projects for the challenges that are forthcoming?
I think this goes back to, I think Will said it first off earlier. It's about, if it's engaged early enough with regards to design, incorporating the right products that can perform acoustically and will continue to perform acoustically. If you incorporate those into your build, your specification, it will future protect you for a number of years.
Okay, I've also had a question come in about like the different components. So as in how to know whether you've got all your components right. Is it the best way essentially just to talk to someone who's an expert? I mean, I guess that's usually the case, but you know, in terms of acoustic fabric panels and that sort of thing, like how do you make sure that all your parts are working together and you're not actually being counterproductive by using different components?
I'd say that the best thing to do where possible is to look for tested solutions. So you know, rather than sort of prescribe your own build-up, stick to something that has actually been tested in a lab and is, you know, known and sort of tried and tested, you know, proven to work and to do the job. If you do want to go down a more bespoke route where there's not test data, then perhaps engage with the manufacturer. I mean, we're happy to take on to some degree to help with bespoke testing or project-related testing. Maybe we can get something done there, or you know, speak to an expert. You know, either one of the acoustic consultants here, or you know, there's bodies like the SRL, acoustic consultants that can offer more independent advice. But yeah, so I'd say in summary, try and stick to tested systems. That would be the easiest way forward.
We've also had a question coming in specifically asking about sports halls, which I know was touched on in the presentation, but specifically if you could provide any more guidance on, you know, making sure they are delivered more acoustically suitably than perhaps traditionally they have been.
So yeah, from a sports hall perspective, it is, for example, the ROCKWOOL acoustic infill doesn't satisfy all the requirements wherever you're using a perforated deck, and a sports hall stands out more than ever because of how open that space is. The other factors you have to take into account, as we've covered, are the airborne and the impact levels. So if you use one of the systems that we offer to the market, it's very rarely can we not satisfy the requirements of a sports hall criteria. So if we took at the moment typically a 0.15 thermal performance, if we've got a perforated metal deck, let's say a Tata D60, You put the ROCKWOOL acoustic infill into the perforated deck. You would then have your vapor control layer. You've then got 255 mil of ROCKWOOL Hard Rock DD Multifix to give you your thermal performance. You then cover the roof with a single ply or a bitumen system or even a liquid system. That system will then, as I just touched on, it performs thermally to 0.15, but it will also satisfy the criteria required by the majority of schools. If that school is being built in a really noisy area, obviously we would request the acoustic report so we could review it to ensure that that system still does perform. It may be that we need to add a layer of acoustic membrane, or we take the insulation thickness up slightly to overcome what is actually required. We just try to make it as easy as possible. So 2 layers of roof board and the acoustic infill, and you should satisfy the criteria for a sports hall.
Okay, brilliant. We've also, which I know that you guys did cover off, but it's just, I think people are looking for some more details on the differences between new build and refurb projects, and just, you know, sort of how first of all, I guess, how come there are those different requirements? Is it essentially just because it's too hard to retrofit to new build standards? And also, you know, what that means in a practical sense in terms of the different requirements of installation of products and that sort of thing.
Yeah, I mean, a lot of it comes down to practicality, and you know, what's actually feasible, you know, given a set cost and given kind of the limited outcomes you can get with refurbishment works. I mean, I think the key lesson there is that it's important to get it right the first time, you know, with a new build when you're actually you know, the design stage early on, so that you don't have to come back with these retrofit measures. I mean, granted, a lot of the places that will be retrofitted, it's more to do with it'll be buildings that will predate the existing regs anyway. But yeah, I'd say it's the most important thing is to get it right first time. I mean, and the fact that they've had to recognise that in the regs and give us sort of allowance in terms of the targets for refurbishment is kind of a sign that, you know, any kind of works afterwards will only be limited in their effectiveness, what they can do.
Brilliant. We've also had a question come in about the use of MMC and offsite and how this all interplays with the government's push. I mean, we touched on net zero, but the other big DFE thing is the presumption of offsite and modern methods of construction. So how does all your systems sort of work in with that?
So we are actually involved in a number of off-site constructions. Obviously, the risk with off-site is when you actually get it to site and piece it together, you've got to make sure there's no gaps there. So we've spoken to a number of the guys involved in off-site, and I'm involved. I know it's not a school, but I'm involved in a hospital facility at the moment, which is undergoing exactly the same thing. And one of their key concerns is when it all gets put together on site, how does that actually come together? So they've had assurances from others to say how it can work. We've put a few ideas forward to say that, you know, you could, if it is a double-layered roof system, as an example, you could install the first layer at the factory. The parts then get transported to site. You could then finish on site by installing the second layer of roof board and then waterproof it if that's an option. But yeah, going back to if it is all done off-site, we are involved, and it just comes down to just limit that risk as much as possible on site, ensure that everything is done correctly with the correct products, and it should perform once it's installed.
Brilliant. We've also, just because I think I probably mentioned net zero again there, there's been another question about, obviously you were saying that yours is based around, you know, using stone, and that's the basis for your products, which means that, you know, you need to, that works in that net zero environment. So in terms of schools looking to be delivered to help achieve net zero goals now, you don't need to pick, essentially, is the question. Is it possible to deliver all the standards that you need at once?
You taking that one, Will?
Well, yeah, I mean, certainly if you look at a product like ROCKWOOL, if you think of everything that you have to meet in terms of building regs, I mean, when it comes to things that insulation can do, well, you're looking at fire performance, acoustics, and thermal. And it's the one product that can do all three. You can turn a wall into a firewall with ROCKWOOL and get a fire resistance rating. You can, obviously, it'll give you a DV rating in a wall with the absorption that it offers, and it's also thermally performing as well. So, you know, it's one product that kind of ticks all three boxes. So in terms of meeting those kind of goals, I'd say it's not a bad choice.
Brilliant.
Sorry, John. Just to add to that, I know I am involved with a number of NFIT schemes at the moment on the school side, and then we're also involved in a number of passive house projects as well. And it's been deemed that our product is a very suitable fit for both of those because it will perform so long during its lifetime. It'll perform to the same level during its lifetime, and it will be there basically for the lifetime of the building. So hopefully that gives the question asker on that one a little bit of comfort. But obviously, if they need anything further, please feel free to.
Yeah, I mean, in terms of longevity. Sorry?
Oh, sorry, I was just saying, just to be clear, you were saying that it's suitable for passive house schemes as well?
Yes.
Perfect. Sorry, Will, you continue.
I was going to say, in terms of longevity of performance, there's I think some relatively recent research done where they took some mineral insulation out of a building that was demolished in Germany and proven that it maintains the same performance for at least 55 years in situ. So there's no degradation. So if you put ROCKWOOL in a building, it's going to be performing thermally and acoustically for the duration of that building's existence.
Brilliant. We've also had a question come in asking for, what sort of, in terms of acoustics, what should different trades be focused on? Like, what should different specialisms keep in mind? Because obviously there's, MEP people on the call, there's project managers, there's cost managers, there's a whole range of different structural engineers. And everyone's sort of wondering, whose role is what exactly in ensuring that everything gets delivered fully?
I personally think it's a part of everybody's role, because everybody's part of the project. And like I said earlier, when we advise and guide people, we then become part of that project. And as an advisor, we have to make sure that we're correct in what we're advising. And we think everybody that else is involved in that chain, from when that project is concepted right the way through till it's in use by the client and whoever is then maintaining that building, I think it's the same responsibility right the way through. There's kind of a sense check for everybody involved to make sure that everything interacts together, works together, so the building can perform how it needs to perform.
Brilliant. Okay, we've only got a couple of minutes left, so I think maybe a good way to wrap things up might be if I could just ask you both to sort of highlight your top couple of takeaways for people, so they can go away and tell their colleagues who can then come back and watch on our on-demand link. And that, I think that would be a nice way for us to wrap things up.
Over to you first, Will.
Cheers, Justin. Yeah, I'd say when it comes to anything to do with acoustics, including any BB93 considerations, the earlier you make these, you address this, the easier it will be. So involve us in our technical department and Justin as early as you can to make sure we get on the right route. That and tested solutions. Tested solutions are what you should look for. Yeah, Justin.
Thanks, Paul. Well, I would say, yeah, take away that tested solutions is certainly the way forward. Third-party accreditation, and try and look for the simplest path. And the one thing I will highlight here is we always sort of get asked to compare ourselves to other systems. Other systems often need multi-layers. We've taken it back to basics. We make it as simple as possible. So we're here to help. We're here to support. And yeah, if there's any questions, please feel free to ask, and please recognise BB93.
Brilliant. Okay, thank you both so much for your time. And I'd also like to thank our audience who've been really engaged and sent through some really great questions. And I'd also like to thank ROCKWOOL, who sponsored today's session. So that's also always really great. As I said, we've still just had someone come messaging asking if they can get this and access to this afterwards. Yes, it's available on demand. Same link within 30 minutes, you'll be able to watch it all over again. And that video will be attached to that link as well. So you'll also have that. I'd also just like to flag that our earlier session from today about the school building program is also available on demand, all from our events page and the building homepage and building design homepage. So that's it from me. Big thank you to Justin and Will, and goodbye.
That's great.
Thank you, guys. Take care.